Hey guys, today's lesson is the last lesson. It's on imaginary and complex numbers. This is your last lesson of the year. Congratulations, you made it. On Wednesday, I'm uploading a review. Okay, so it's going to be a review you can take on Edulastic. It's going to be very similar to your final. It should give you an idea of what to expect. Okay. All right. So, imaginary and complex numbers. If you haven't already, please watch the other video that I linked on YouTube. They kind of just give you an intro to imaginary numbers. They talk about them. I think it's very interesting. I show it every year in class anyway. So just go ahead and watch it. And if you did, let's go ahead and get started. So imaginary numbers or complex numbers, it's the same thing. They're always written in the form A plus BI. Okay. They have a real part and they also have an imaginary part. Okay. Now, this is interesting because even our regular numbers, like the number 5, is technically, it could be written as a complex number if we set our B equal to 0, okay? Because 0 times I is just going to be 0. So this is really just 5, but just keep in mind that even our regular numbers like 5, 0, -1, -15, they could be written as a complex number, okay? I just wanted to show you that. But anyways, okay, so just keep in mind that complex numbers are written in this format. You write the real part first and then your imaginary part. I also want to talk to you about I. So I'm just going to make some notes on the side. So I is equal to the square root of -1. Now, in math, they've always told you that you can't take the square root of a negative number. Well, you can. It's just an imaginary number. So if you take the square root of a negative number like -1, it's I, okay? Now, there are different powers of I. So you could take I squared, okay? Now, I squared is just the square root of -1 times the square root of -1. That's just I times I. Okay, I took that from above. Now we learned with radicals that if you have, I'm just going to rewrite these together under one radical. So -1 times -1. Now we've talked about pairs before, and we've said that if you have a bundle of something in a radical, you can just pull it out of the radical. So this is really the square root of, and I'm just going to rewrite it for you, -1 squared. And the square and the radical, we know, cancel each other out. So these cancel each other out. So this is really just -1. So I squared is -1, okay? Now let's talk about I cubed, okay? I cubed is the same as I squared times I. We know from working with exponents that if you have the same variable, you just add your exponent. So this is really I cubed, okay? I'm just working backwards a little bit. Now, from above, I know that I squared is -1. So I'm just going to rewrite this here. So I squared is -1. And then we know that just I is the square root of -1 from up here. Okay, so this really is just the square root of -1 with a negative outside. Okay, so this -1, I just took the 1 away and just wrote it outside. Okay, so we know I so far is just the square root of -1. We know I squared is -1, and we know I cubed is negative square root of -1. Let's talk about I fourth. Okay, so I to the 4th power is really the same thing as I squared times I squared. And that's because, again, if you have the same variable, you add your exponents. So this is I to the 4th power. So again, working backwards, I know I squared is equal to -1. So this is really like -1 times -1, which is a negative times a negative is a positive, and then 1 times 1 is 1. So this is really just 1, okay? Now, I'm going to start moving on. I'm going to talk about I to the 5th power. Now, I to the 5th power is the same thing as I to the 4th power times I. Okay, and you can split this up whatever way you want to. You could say it's I cubed times I squared. You could say it's I times I times I times I times I 5 times. Okay, but let me talk about I to the fourth times I. So I to the fourth is 1, and we know I is the square root of -1. Okay, so 1 times the square root of -1 is just the square root of -1. And you can tell that if you keep going with your cycle, like if you talk about, if you talk about I to the 6th power and then I to the 7th power, it's just going to cycle. So I to the 5th power is actually the same thing as I, okay? I to the 6th power is actually going to be the same thing as I squared. I to the 7th power is going to be the same thing as I cubed. And then I to the 8th power is going to be the same thing as I fourth. So this shows you that actually anything to the 4th power, or that's a multiple of 4, like 8 or 12 or 16, is going to give you I to the 4th, which we know is just 1. Okay, and that kind of works the same way for the other ones. I'm going to erase this because I want to work through some problems with you. So these are just some notes that I wanted to talk about, and you kind of need these and you need to understand them before we move on. Okay, so I cubed. Now we know what I cubed is. I wrote it up there for you. So we know I cubed is, the negative square root of -1. You don't really need to show any work for this one because it's already on our table. So I to the 1st power through I to the 4th power, you don't need to show work. But everything else you do. I'm going to do all the odd problems with you, by the way, and then for homework, you're going to do all the even problems. Okay, I to the 20th power. So for I to the 20th power, now we don't want to continue our table to 20. So what you want to do is take your exponent and you're going to divide your exponent by 4 every time. Okay, so 4 goes into 20 5 times. 5 times 4 is 20. You subtract, you're left with 0. So this is 5 remainder 0. Now, here on our table, this is how you can read this. Okay, so on our table, if you have a remainder 0, this is like looking at I to the 4th. That's going to be remainder 0. If you have a remainder 1, that's going to be like I to the 1st power. If you have a remainder 2, that's going to be like I to the 2nd power. And then a remainder of 3 would be I to the 3rd power. You can't have a remainder of 4 since you're dividing by 4. Okay, so because I have a remainder of 0, then it's going to be the same thing as I to the 4th, which we know is 1. So my answer here is 1. Okay. Let me try the next one. I to the 106. Again, you don't want to draw your table. You just want to take your exponent and divide. So what I'm going to do is take 106 and divide by 4. Okay. So 4 goes into 10 2 times. 2 times 4 is 8. Subtract. I'm left with 26. I know 6 times 4 is 24, so I'm going to try 6. 6 times 4 is 24, and I'm left with 2. Don't do decimals. You're going to use your remainder, okay? Because I have a remainder of 2, because I have a remainder of 2, I'm going to use my remainder 2. So my remainder 2 is this one here, which I know is I squared. So this is the same thing as I squared, which I know is going to give me -1. Okay, and that's my answer. So this is how you do these problems where you simplify. All right. Number 7. So for number 7, you have the square root of -8. It's not no solution. You can actually simplify this now. So what you want to do is you want to split this up. Okay, so this is really the square root of -1 times 8. Okay, now we know the square root of -1 now. We know that that's just going to be I. Okay, so whenever you see a -1 in there, take it out, call it I. So this is what you have left. Now, you would be done if you couldn't simplify the square root of 8, but you can. So just keep simplifying. You can make a factor tree if you want. I know the square root of 8 is 2 times 2 times 2. Okay, remember to take out your bundles. I want bundles of 2. So this is really going to come out. Make sure you put your numbers in front of your imaginary numbers. So this is 2i radical 2. You can also write this as radical 2 with the 2 in front and then your imaginary number at the end. This is actually the preferred way to write it. So your coefficient, if you have anything that you're able to take out, your radical, and then your imaginary number goes at the end. okay? You're going to try number 8. Number 9, okay, so for these, you're just going to simplify. So for number 9, it's asking you to subtract, and you have some stuff going on. Now, keep in mind that your real numbers could only be combined with real numbers, and your imaginary numbers can only be combined with imaginary numbers. So I'm going to start with my real because, again, the way that you write a number is real first and then your imaginary part, okay? So for this one, if I add -1 plus -4 or -1 minus 4, that's going to give me negative, oops, wrong color. It's going to give me -5, okay? And then now my imaginary part. So I have -8i minus I. Add your coefficients. If there isn't one, it's a 1. So this is -9i, okay? And this is my solution. You have your real part in the beginning. This is my real, and your imaginary number at the end. Okay, you're going to try number 10. All right, number 11. All right, for this one, you're actually multiplying. So you're going to FOIL. You're going to multiply this all out. I'm going to do it in a few steps for you. Okay, so for the first part, I'm going to multiply this 4 inside to everything. So this is going to give me 4 times 4, which is 16. And then 4 times I is just going to be a positive 4i. Okay. For the next one, I'm going to multiply -5 times 4. I'm sorry, -5i times 4. That's -20i. Treat your I like a variable right now. And then -5 times I, I'm sorry, -5i times I is going to be -5i squared. Okay. Now we learned above that I squared is equal to -1. So you need to change this to a -1. Okay. So it's going to be -1. Bring everything down. Okay. And then combine your like terms. So here I have i's that I could combine. I'm going to get 16 minus 16i. Remember to combine your coefficients. Negative times a negative is a positive 5. And then now I can combine my 2 real parts. Okay, so here I'm going to have 21, and I'm going to put that first because that's the real part of my answer, and then minus 16i. Okay, this is my solution. All right. One more problem I'm going to do for you, number 13. Oh, nope, there's no number 13. So you're going to try all of the even problems. Again, the most important stuff is up at the top in the notes that I wrote for you. Remember, imaginary and complex numbers could be written in the form a plus bi, where a is the real part, b is the imaginary, and then you have cycles of I. So from I to I fourth. For the other ones, you don't need to continue the table. Just divide by 4 and then look for your remainder. Make sure you guys email me if you have any questions. Bye.